There are a couple different ways you can factor depending on what your original polynomial looks like. In a previous video, we discussed dividing out the greatest common factor. This video will discuss the difference of squares. You should always try to do this method first and then try one of these other three, depending on how many terms your polynomial has. So the difference of squares is this pattern here. If you have two numbers that are squared and they are being subtracted, then you can factor it into a plus b and a minus b. I took the square root of a squared to get these two pieces. I took the square root of b squared to get these two pieces. And then one of them has a plus and one has a minus. I remind myself of the pattern plus and minus because whenever you square root something, you can have a positive or a negative answer. So this is just a pattern or an identity that you should recognize. Examples: 4x squared minus 9x. The first thing you should do is always check to see if they have anything in common. 4, 9, there's no number that they have in common, so done with that. The second thing is, I have two terms here. I can take the square root of 4, I can take the square root of 9, I can take the square root of x squared, and I'm subtracting. So that means I can use this pattern, this difference of squares pattern. I'm going to have two pieces, two factors here. Square root, the square root of 4 is 2. The square root of x squared is x. Square root, the square root of 9 is 3. And the pattern is to have 1 plus and 1 minus. Most common thing I see here is people forgetting this is a factor and they just write that. But remember, factoring and multiplying are opposite actions. So if this is my answer, what am I going to multiply by to get back the original equation? All right, second example, 18x squared minus 2. You may be thinking, I can't take the square root of 18. But that is because I wanted to remind you, divide out the greatest common factor first. You can do multiple things when you're factoring. So in this case, 18x squared and minus 2, I can pull a 2 out. And now my 9x squared, I can take the square root of that. And my 1, I can take the square root of that. And I'm subtracting. So I can break this parentheses, this second factor, down even further. You should always double check to make sure that you can't keep breaking things down using one of these four methods. Okay, let's square root 9x squared. Let's square root 1. And the pattern is to have 1 plus and 1 minus. Don't forget the original 2 that I pulled out front. You have to have all three pieces here, and you would multiply or distribute them all back together to get the original polynomial. You may want to pause the video to try these last three problems. I can square root the first piece, I can square root the second piece. There was a minus sign between them, so that means I can use this pattern here. Done. This example is not an x squared, but I wanted you to know that as long as your exponents are even, then that means it's square rootable. You can take the square root. And when you do the square root of an exponent, divide by 2. So if I square root 4, if I square root x to the 4th, 4 divided by 2 is 2. If I square root 9, and the pattern is to have 1 plus and 1 minus. You can double check to make sure that I can't square root both of these to break this second piece down even further. But the square root of 2 isn't a nice pretty number. So same thing, the square root of 3 is not a nice pretty number, so done. All right, last example. I need to pull out a 3x first. Now, 4x squared and 25 are square rootable, and they have a minus sign between them, so I can use the difference of squares pattern.